welcome to the SSI Orbit podcast, a forum for conversations that explore the ever-growing ecosystems of self-sovereign identity. And I'm your host, Mathieu. Okay, so I was thinking to start this conversation today, which will be diving deep-ish, let's say, into OIDC for verifiable credentials. I think it would be a good starting point, since OIDC is in the name of this thing, to just take a step back and just talk a little bit about the history of OIDC and the history of OAuth, because I know there's certain pieces that are used inside of the OpenID for verifiable credential specifications and some aren't. So it maybe would be an interesting way to start, just taking a step back and looking kind of how we got here.
So then we need to go back to 2010. So around that time, the work on OAuth 2 and OpenID Connect started. And OAuth basically is a mechanism that was initially intended to solve a very simple problem. You've got an API, but you do not want to send user credentials to that API or give your user credentials, your username and password, to a third party. For example, the photo editor app, you don't want to give them your password in order to be able to access your photos, for example. And that was the reason why OAuth was invented, right? To get rid of that problem. But OAuth 2 was the next step, because it allows to really secure APIs on a broad basis, very scalable, very secure, and so on. I did a security threat model for OAuth 2 back in 2010, 2011. That was the first step. And nowadays, OAuth is everywhere, right? OAuth 2 is everywhere, used to secure APIs. And around that time, people were working on a new version of OpenID. I mean, OpenID had been around for a couple of time at that point in time. And they thought it would be a good idea to base the identity protocol, because OAuth does not reveal identity, right? That is a fundamental principle of OAuth. OAuth just gives you access to something, but it does not reveal the user identity. And then the idea was to say, let's put OpenID Connect on top of it and utilize the fact that the server that does the authentication already knows the user, has some identity data, and it can then reveal with the user's consent to what's called the relying party. So OpenID Connect was built on OAuth because it was there, it was simple. And that's a big success story in the end, because OpenID Connect is implemented all over the place. A lot of big players implemented it, but also, I mean, it's huge in small businesses as well. I have been working on, or have worked on, in the mobile space. I used to work for a mobile operator. We did something called Mobile Connect, which in the end made every mobile operator on OpenID Connect OP. And in the last couple of years, I contributed to building an open banking ecosystem where more than 1,000 financial institutions expose their identity capabilities using OpenID Connect. So that's the pre-story to the story of OpenID for verifiable credentials. Now, what is interesting, in OpenID Connect already, and I think it was published back in 2012, it already had an idea and an option that was called self-issued OP. So contrary to what people typically think, OpenID Connect was never built just for the big centralized federated identity system. It was always built with the idea in mind to support different kinds of architectures. And the self-issued OP basically means that the user can, on his own or her own device, run an OpenID Connect OP that it fully controls, right? And we started to work on OpenID for verifiable credential, which had a different name at that time. I think at the beginning of 2021, it was around the first COVID lockdown. And Decentralized Identity already had gotten a lot of interest. There were other protocols available, DITCOM, for example, right? And we thought, well, let's try to build something that is optimized for the use case, for the identity use case. I mean, we will come back to what the difference is between OpenID and DITCOM and so on, but we thought, I was working at that time on OpenID Connect for identity assurance. So for using OpenID Connect for the substantial and higher assurance stuff. And we thought, well, let's take a look into whether we can use that for a decentralized identity. I mean, long story put short, we learned over time, well, that's a different animal. So we need to approach that with fresh eyes. And luckily, the OpenID community, or there were other people joining the OpenID community, young people, energetic, enthusiastic that joined the community, and we were able to really gather a team with experienced identity dudes and new and fresh blood, and together we started to work on an OpenID that is really native to decentralized identity and verifiable credentials. So nowadays, what we're working on is called OpenID for Verifiable Credentials. It has the OpenID in the name, but it does not have the OpenID Connect, for example, in the name, because it's different. OpenID Connect is the thing that is federated, right? That is built for the federated trust model, with the exception of SIOP, which means there is an identity provider, and someone who wants to get identity data reaches out to that identity provider, and that identity provider in real time issues an identity assertion that you can consume, which means that this identity provider is always involved in a transaction, right? And with decentralized identity, we wanna have a different concept where the function of an identity provider is split, right? You've got that party that issues something about you, that knows something about you and can assert something about you, which is the issuer. And you've got a wallet where the user stores that credentials, right? So the functionality that is in federated system in the IDP or OP, because it asserts the identity and it also provides the identity to the relying party, is split in those two different elements, which increases privacy, but also increases complexity tremendously. Because you need to make sure that the wallet also handles your credentials securely, that the credentials can, for example, disclose selectively. So if you have an identity credential, you do not want to disclose all your information, you just want. So it's really complex. And it also has obviously more interfaces, because you have an interface between the entity that issues things and then the interface for presenting things. And over time, we developed a protocol suite that addresses those functions, and we based that on OAuth. Why did we start with OAuth? Because OAuth is a very solid basis for doing interactions between those parties. And especially in the issuance case, it's super simple to set up an API to issue credentials and to secure that with OAuth. So it's really, really very useful. And we do the same on the presentation side. So it's based on OAuth, but the protocol itself, the OpenID part of it, is really truly native to verifiable credentials.
A lot of info.
Yeah, because you can just stop me.
No. It's great. You covered a lot. Is there enough kind of overlap? Because I think, as you kind of mentioned earlier, the adoption that exists today and is probably continuing to grow over OpenID Connect or just OpenID Core, and also just OAuth usage, runs a big part of our digital lives today. It's so entrenched in so many things. Is there enough overlap between this and OpenID for Verifiable Credential that existing kind of implementers of these technologies are seeing it as an easy on-ramp to start issuing or accepting verifiable presentations versus the existing model? And does stuff like the self-issued OP kind of add complexity there, or is it just enough of like, we're speaking the same language that it makes it easy enough to implement? And the reason I ask is, I think when anyone gets into the decentralized identity space at first, there's just so much to learn, so much to try to understand, and it honestly never ends. And personally, doing this podcast, it never ends. You kind of get a good understanding of the different pieces, but your learning never ends, which could be scary at times to want to dive deeper or make investments. So is there enough overlap between kind of this history of some of this federated implementations and non-federated through OAuth and OpenID Connect and OpenID Core that it's less scary for implementers that are coming from this world to jump into the, let's call it, the decentralized ID world?
I mean, I will first answer the question regarding the people that have already implemented OAuth, and then would also like to just talk about the newbies, right? So if you look under the issuance, on the way we designed the protocol for the issuance, you will see that this is very much a very similar design to OpenID Connect core. So you use OAuth to actually authenticate the user, authorize the credential issuance. And then instead of the user info endpoint, you've got a new endpoint, which is called credential issuance endpoint. So the model is very much the same. And this also means, and we have tested that, if you have an existing OpenID Connect deployment, what you do is you add a new endpoint to actually issue credentials. In the end, it's all just signed assertions, right? So, but the protocol and the setup is more or less the same. You use authorization code flow. You can use the additional security mechanisms like pushed authorization requests, FAPI2. You can use sender constraint access token, all that stuff to make it secure. The big difference is in the credential issuance endpoint, because issuing a credential is a bit different than just returning user info. First of all, you want to have a cryptographic holder binding typically. And cryptographic holder binding, that is something that you do not have in OpenID Connect core because you do not need it, right? The cryptographic holder binding is something you need because of the indirect model. Because if something is presented from the wallet, the recipient doesn't know whether that was really presented by the legitimate holder.
Is that why, like, when I was looking at the two different protocols for presentations and for issuance, so they're written differently, right? The presentation one is OIDC for verifiable presentations, which would say that there's the connect or the core in there. Versus
there is no C. There's no C in the name. There's no C in the name. It's OpenID for verifiable presentations.
And then it's the
and
same
it's
thing.
Also OpenID for verifiable credential issuance, because the OpenID for verifiable credential issuance, we started it as an OpenID Connect extension. And then we realized for existing deployments, that's fine. But for new implementations that want to use the protocol, they said, I just want to issue a credential. I do not want to issue an ID token. And this is something you must do. If you implement OpenID Connect Core, you must issue an ID token. And for those that just want to issue credentials, a developer asked me, well, why should I create an ID token just because the protocol forces me to do so? And that's why we stepped back and said, okay, then let's just make it a simple OAuth protected API, but we're using patterns that we know from OpenID Connect Core, right? So on that end, the issuance is pretty much similar, and you can build that on top of existing OAuth implementations and OpenID Connect implementations. We have done that in prototypes already in 2021, so that works very well. The presentation side is a bit more difficult, because on the presentation side, you typically assume that, or we try to do most of the processing on the user device or in the user wallet, and we do not want to force the wallet to need a backend. So it shall be possible to implement a deployment model where the wallet just resides on the user device, which somehow limits the capabilities of the wallet acting as an OAuth authorization server, right? And that's why typically what is being used is a flow where the request is sent over the front channel and also the response is sent over the front channel. We could also use an authorization code flow, right? But it requires a token endpoint and all that stuff. That's possible with OpenID for verifiable presentations, but most people prefer to build their wallets with that thin layer that just does a redirect back and forth. So this is something where I see the biggest deviation from what is today typically done in OAuth. And this is also the where new libraries for OpenID4VP are needed. And I mean, the protocol is so simple. Most people start by just implementing it on top of their HTTP client, right? It's pretty simple. It's just parameters. But there are libraries already in the wild. I'm familiar with 3 of them. So this is growing, but we need more support on that end, clearly.
Within the stack, what are, and maybe you could talk to how OpenID for verifiable credentials is able to work with different signature schemes or work with different credential types. It seems like there's elements of it that is able to leverage what other communities have kind of contributed over the past years, and there's other elements that are kind of native to here. So yeah, if you can maybe just explain a little bit that and why perhaps like these new protocols were built versus using other protocols that exist out there today. So there's been some sharing and there's been some just new stuff being built. Just explaining why these two decisions were made.
And that's a very important point. So if you compare OpenID Connect and OpenID4VC, you will realize that OpenID Connect core exactly defines the format of the identity assertion that is being issued. It's JSON, it's a JSON web token. That's it. The situation in decentralized identity is completely different. There has been a lot of work done in different credential formats. There is the Indy stack with the AnonCred format. There is the Glyph stack with ACDC and Caesar. There is SD-JOT, there is JOT, there's JSON-LD, Open Batch, and so on. Completely different credential formats designed for certain use cases and purposes. And for me, this is more an emerging market, which is totally exciting to be in it, right? if you need to meet a decision in a development project, it's really scary. But basically, you can't. I mean, everybody agrees on yes, it would be cool to have one credential format. That's what we can agree on. But there is no agreement on what that credential format would be, right? We did at IIW, we did a survey of credential formats, and we came up with a list of 16 or 17 different formats, right? And I just ask a very, very simple question. What's the best credential format, right? So, and the point I want to make is we decided very early on in the process that OpenID Connect, OpenID for Verifiable Credential should be providing interoperability on the credential exchange layer, but should not force or prefer a certain format. To the contrary, we wanted to really leverage the work that other communities have done and allow people to decide what credential format they can use. The first prototype we did, for example, in a project I'm working in, was to use OpenID4VP in conjunction with AnonCreds. Can you believe that? I mean, and it worked well. It really worked well. So, and over time, there were other people implementing it with other protocols. So today, for example, OpenID4VP and VC is part of the ISO MDL specification, which has a completely different credential format. It's called MDoc. It's a binary credential format. So we were able to show that you can utilize those different credential formats, and with that, their unique capabilities, but rely on the same protocol layer, which at least gives us a bit more interoperability than we had before. Because what you otherwise see in the market is, with the exception of DITCOM, most other stacks come with a credential format and a proprietary protocol, which means you can't really come to a combined presentation, for example. You have to implement a new format to get access to a certain kind of credentials. And this is really an obstacle for adoption. And we try to at least contribute to more interoperability and adoption by providing a simple to use, secure, and universal credential agnostic protocol.
We get questions a lot on kind of what direction should we go in, what protocols should we use to do credential exchange, trust tasks, what credential formats are best, stuff like that. And I think kind of as you touched upon, there are different ones that have different unique capabilities or properties that are good for certain use cases and maybe overkill or maybe less good than another option for other use cases. And so there's strong push, and we're very familiar with the whole AnonCred world today, just doing a lot of work in the public sector. There's a lot of really good privacy preserving benefits in these credentials that are quite appealing to public sector to issue credentials to citizens. And just talking to Andrew Hughes on a previous podcast about the whole ISO MDL world, there's a lot of good benefits and there's a lot of interest. And it seems like it's just an easier step to starting to issue these types of credentials because there's a lot more comfort of these things being an ISO format. It's based on a particular use case. So it's quite interesting that, and seems like a very smart decision that it's just like, okay, there's no point in us just locking into something proprietary. We want to make sure that we have that flexibility to be able to support different use cases. But underneath this transport, like, and maybe it's a good time to start talking about something like DIDCOM. in the Trust over IP Foundation, and I know you're familiar with this in conversations with Drummond and some other folks in there, with the new architecture design that has come out of the Trust over IP, where, and I've repeated many times how I'm a big fan of this architecture. It simplifies a lot of things. But if we're talking about the credential exchange trust task, which they throw on, and we'll put a link to this specification in the show notes for anyone that's interested, which I suggest you should read. It's a really good paper. But on the trust task layer, credential exchange being a trust task, right here we're talking about credential exchange happening through OpenID for verifiable credential issuance and verifiable presentation. Underneath, on that second layer of the trust over IP, they have a trust spanning protocol, which is still undecided as of today, I would say, of what that trust spanning protocol is going to be. There are contenders. There's a lot of convergence possibly happening between different protocols as well to kind of create this trust spanning protocol. How does OpenID for verifiable credential interact in this model on top of a trust spanning protocol? Is it a trust spanning protocol on its own? Does it fit? Does it not fit in this model?
I'm pretty sure it's not a candidate for the trust spanning protocol. It is, in the end, it is a specialized protocol. It was developed with the intention to address 3 use cases. Use case number 1, credential issuance. Use case number 2, credential presentation. And use case number 3 is the pseudonymous user authentication through a wallet. That's the ToIP use case. And I had conversations with Drummond and other Trust OIP folks. What contribution OpenID for verifiable credentials could provide to Trust over IP and the reference architecture and the discussion. And the idea we came up with is to use it as a support system. I think it's layer 3 in the Trust over IP architecture. Because if you take a look on DITCOM, right? I mean, the goal, the objective is very ambitious, right? To have as Sam called it today, a secure overlay protocol, right? That allows you to securely communicate multi-hub, persistent, secure, and all that stuff. For me, that's a universal protocol, right? It's like HTTPS that we use today in the future. And the ambition of OpenID is not that high, right? The ambition is just to solve that identity problem. And even if you have a DITCOM or another communication channel, right? What DITCOM does basically allows you to establish a authenticated connection. But then if you want to build trust, you typically will need some credentials to establish trust in the other end. And that's where protocols like present proof come into play, DITCOM protocols. And then the question is, how do you implement that as an agent? You can store in the agent all the credentials as it is done today. And if you get a request to present a credential, you can pull that credential out and present it over the DITCOM connection to the other end. That has led to a situation where each and every agent acting on behalf of a user needs to have access to all those credentials. And what we came up with is the idea, well, if the agent is acting on behalf of a user, why not just integrating with the user's wallet, right? I mean, what we would like to come up with is a situation where a user has the wallet, or she has a wallet, has all the credentials, and if she use different apps, those apps just ask the wallet for a credential to be presented if they want to establish a connection to someplace else. And that was the basic idea we came up with, right? Integrate OpenID for verifiable presentation as a layer 3 support system. And the agent, instead of managing its own credentials, uses the interface to call out to the wallet and the user and says, I want to access this service on your behalf. I need this credential. Do you allow me to present that credential to the other end? And then the user accepts that, consents, and the presentation is sent through the DITCOM connection, for example, to the other end. So that's the basic idea, right? And if you want to get a credential, then you can use credential issuance as well, right? Which is quite obvious. And a unique property or unique capability of the OpenID for Verifiable Credentials suite is that you can, during a presentation, also turn around and obtain a credential. Because the wallet and also the issuer can have full screen control. So even if you do not have the right credential in your wallet at that moment, you can try to get that credential and complete a transaction successfully. So that's basically the idea we came up with.
It sounds similar to kind of the origin story of OAuth 2 that you're talking about, just to secure like access to APIs. It could be something similar if we imagine a future world where all of our mobile applications that have connectivity to the internet also have connectivity to a trust spanning layer type of thing to actually facilitate transactions to happen, perhaps to facilitate on-ramping or even access between applications. It could be a protocol being used. Does that make sense?
It absolutely makes sense. I share that observation. There is one, conceptually, I'm absolutely with you. There's one interesting difference. With OAuth, you typically have the situation that the API trusts in a certain authorization solver. So the user needs to go to that authorization solver and authorize the access. With the advent of decentralized identity, we can even more decouple that, because the wallet in the end is becoming the authorization solver, and the user fully controls that and access to all of her resources. But conceptually, I'm absolutely with you. Yeah. And we're already talking, for example, to integrate or to use the wallet in OpenID4VP, for example, to initiate payments, right? Just from the wallet, which is one of the use cases, for example, that the European Union is looking into in the eIDAS-v2.
It seems like things at the end of the day that I think we're on the same page, have different purposes and are going to be abstracted from end users at the end of the day, but they just have different functions altogether. And so it's interesting coming from the whole OpenID federated world. I think there's a lot of momentum behind this stack that we're talking about. In particular, just there's good branding around the whole OIDC space. I think there's maybe good reasons for it to be in the name of this spec, because it creates maybe excitement and people that have feelings of security and really trust this implementation. There's also a lot of differences as well. I guess you're probably seeing when people are coming in from the federated world need a little bit of education as well to be able to grasp some of the differences here. But all these things look like at the end of the day, and that's what I felt after the last Internet Identity Workshop, is you have these different protocols that they clearly have different purposes, and you could clearly see them working together. And like by being able to work together, they complement each other as well.
Yeah, absolutely. I mean, you attended the session at the last IW where we had that shootout, the so-called shootout, and I really enjoyed it, because it was for the first time, for a long time, that people from the different camps really presented to each other their current work. And we looked into each other in a very, very respectful manner. And I really liked that, because that's the way it should work, right? Be respectful with the work of other people and look whether you can do something together. And I think that was a starting point, and I hope it was a starting point to do much more together, because the collective experience, with the collective experience of the people in the wider community, we can build even better protocols, right?
We talked about this protocol being able to use different credential formats that have different properties, which is fantastic. Do other core elements in decentralized identity, maybe more on the identifiers side of things, like decentralized identifiers, are these used in this protocol as well?
Yeah, they are. So basically, you can pick and choose your format, the identifiers for holder and issuer, the crypto algorithms, obviously, and also the trust management mechanisms. So there are implementations around, for example, that use did ion or did web, or for the issuer, did JWK or did key, or even did Indy. And on the trust side, you can use certain different mechanisms to really establish trust between the verifier on the wallet and the issuer, which is very important. It's even more important than in the federated space, because the number of parties in a decentralized ecosystem is much higher. And establishing trust between them is a real challenge. And for me, this is one of the areas where much more work needs to be done. But you can combine the different technologies in the with OpenID4VC. Yeah.
You think OpenID4VC and SIOP are all things that are going to help with the NASCAR problem that exists on the internet today? And maybe this leads us into discussions around just general governance of wallet providers and different solutions. Like, there's a lot of talk now just about trust frameworks and governance and trust registries and stuff like that. And it scares me sometimes to see some of the thinking around restrictions being put on either like technology, like either wallets or solutions, and even restrictions being put around who could do what, like on the verifier side or the issuer side. And I feel like it just kind of repeats federation, which we're trying to get away from in certain use cases. I talked about a couple different things there, but does SIOP and OpenID4VC help kind of eliminate the NASCAR problem we have today? And then maybe it'll be interesting to hear your perspective on how trust frameworks kind of play their part here.
Yeah, very, very important question. So the NASCAR problem, well, what we can do is we can make sure that users can use the wallet of their choice wherever they want. Because without interoperability, you only have point-to-point integrations. And point-to-point integrations always prefer the big players, right? So that's why from my perspective, open standards are very important to give everyone a fair choice, and users also the choice about what wallet or what identity credential, whatever they want to use. So having said that, given the model in decentralized identity, the selection problem is even more difficult, more complex than in the federated world, because you need a wallet, pick the wallet first, and you need to really use the wallet that has the credential that you want to consume with the verifier. So that's really difficult, and that's why also trust frameworks come into play. And my current assumption is that integration and invocation of wallets in certain verifiers will be governed by the rules of a certain trust framework, because that also then comes with the custom schemes that you need to invoke a wallet, for example. In the end, that also gives choice, because a custom scheme automatically invokes the wallet that the user has installed or she has installed on device. And I think we should definitely facilitate a user choice. When we talk about regulation, most of the rules are being defined with the intention in mind to protect citizens, to protect users. Sometimes I kind of understand. So for example, or it's not only the citizen, it's also the issuer. So if you for a moment step into the shoes of an issuer is supposed to issue a credential. If the issuer doesn't know which wallet it's going to issue the credential to, and whether that wallet is really secure and properly treats the credential, do you think the issuer would feel good? Do you think the issuer would take any liability? What happens to that credential? I don't think so. And I totally understand that, right? I mean, I'm more in the issuer space because we are doing an open banking ecosystem. So, and that for me means you need to somehow have a trust relationship between the issuer and the wallet, so that there is some guarantee that the credential is really treated properly. Otherwise, we have a real problem. In the end, users also won't accept this decentralized identity idea if people can steal their credentials, impersonate them, and all that stuff, right? So in order to get it right, wallet and issuer have a really special relationship. And I don't know whether attestation is the right way, or whether regulation or authentication of wallets, that's not decided yet. But I do not assume that an issuer, at least when it comes to substantial high assurance credentials, will release a credential to any place. I don't believe so. And from the verifier perspective, or from the wallet perspective, you also want to know whom you're releasing the data to. Because, for example, in the European Union, as a data controller, you have to fulfill high regulatory obligations, right? If you process personal identifier information, so you cannot just release data to an unknown party. That's impossible. Because if there is a breach, you can't even tell the user where the data is gone. So there is no way to file a complaint or something like that. And this is one of the reasons, for example, why in the European Union's eIDAS regulation, there is text saying that they call it relying parties. I don't know why. It feels familiar for me, right? The relying party needs to be registered at least. So the wallet can display to the user what entity will receive the data. And I think that makes sense, right? In the same way as you have an imprint on a website, you know what party you're going to release the data to. Sometimes those regulations are a bit too strict. So for example, there are ideas, every relying party needs to really register and get vetted what use cases it uses the data for. That's too much. That's too much from my perspective, because this is an administrative nightmare. And it also is in the end, government would be somehow involved in the business of those guys and that's, I don't think that's a good idea, right? And it doesn't also help to protect people, right? It's administratively, it's a nightmare. It doesn't scale. And in the end, at least in the European Union, we have other laws in place that make sure that the recipient of the data, if it does not properly process the data, it is fined, and it's truly expensive.
I share the same feelings as you. I think it's, to your earlier point, I think the number one objective is to protect citizens, but at the same time, the more restrictions you put in place, the more, like you said, there's kind of overstepping into the private sector, into the use cases, the business rules and stuff like that. And so it's just trying to figure out where to draw the line, specifically if we're talking about, I guess we're specifically talking about public sector wallets type of thing here, where there is a high valued credential in the wallet, and it could be dangerous if this credential is shared with nefarious parties. But at the same time, it's just, do you need to put strict guardrails, or do you need to maybe think about just putting more kind of indications in the user experience, saying, hey, are you sure you want to do this? Because maybe it's, it's not on our list, but we're not stopping you from doing it at the same time, because maybe it's a good thing that you're doing, or you know what you're doing. So it's just trying to draw that line, I think, is a very tricky thing that a lot of, at least public sector builders of wallets, are trying to figure out right now.
Yeah, and the whole regulation is still in flux, right? I mean, in the European Union, and we will see a period of I guess 2 or 3 years where so-called large-scale pilots are being conducted, and I hope in the course of those pilots we will see what users really demand, what we need to do. I personally think people should really meet informed decisions, but they shouldn't be restricted in meeting the decisions, right? The regulation should make sure that they can, as I said, they can file claims or sue someone that does things with their data that they are not allowed to do. That's fine, but I would not overstep that part. But let's see. I mean, in the end, if citizens don't like the solution, they won't use it.
Are there other aspects, and you said something before, which was, I think, an interesting quote, is that wallets are becoming authorization servers. Are there existing frameworks that are in place today that OIDC for verifiable credential could use? Like, for example, consent management. I think these are things that are trying to be figured out with every single implementation of how they're managing that. Are these things that are existing today that could be reused, that could be part of this wallet being the authorization server, that could, in fact, to what we're just talking about, help protect and inform the holders?
I mean, in the end, informed decisions require transparency. And whatever we can do to make things transparent, tangible to people, we should do. I haven't thought about a concrete technical solution for that, because in the past, authorization servers typically did that on their own. So you have some way to browse in a portal to see what transactions you have authorized, what parties have access to your system, and this is also written down in the European Union's eIDAS regulation, right? You have to maintain a log and all that stuff. I'm yeah, I mean, we need to take a look into that. I think during the large-scale pilots, what other technical standards could be utilized and would be valuable. There is this, don't you were familiar with that? There's called the architecture reference framework that is defined by the so-called expert group, and they define the architecture and also the so-called toolbox, the list of standards that either are mandatory to implement or recommended for implementation. And I think we will see an increasing number of standards in the RF in the toolbox that are being recommended or even made mandatory for wallets and implementations in the EU.
One of the big benefits of using digital credentials in certain implementations of protocols is that in a verifiable presentation, you could use more than one credential or different attributes from multiple credentials that could come from different sources to help in your authorization decision or whatever you're trying to do. This is something that is impossible or difficult to do in a lot of the current models that exist today. Does OpenID4VC verifiable presentations enable this to be done as well, where I could have multiple credentials coming from different sources, and perhaps they could even be from different credential formats, and I could use multiple of them in a presentation? Is that doable?
That is doable. I mean, we know that different use cases use, unfortunately, different credential formats. So university degrees or diplomas are most likely being issued in open batch, JSON LD. Driver's licenses use MDoc, and yeah, there are other. So we do not prevent anything that is supported by the credential format. So for example, if you use AnyCreds, you can use a proof that contains data from different credentials. So that's built into AnyCred. You then put that presentation in what we call the VP token. So the VP token is the container that you use to ship the presentation in whatever format you want from the wallet to the verifier. And the VP token is defined in a way that it can contain multiple artifacts, which means if you're presenting an AnyCred, you can alongside also present a JOT-based credential, for example. It's that simple, right? And we use presentation exchange as the language to specify the request, and also to give additional metadata about what is being presented. So you use the so-called presentation submission, which is another object that is defined in PE, and it tells you, okay, for that requirement that we send, I'm presenting you this credential, and you find it on index number 2 in the VP token. So short answer, yes, it's possible to present multiple credentials in the same presentation, and also to present multiple presentations in different formats in the same transaction.
What was the choice behind presentation exchange being used for the verifiable presentation implementation? Is it just a story of being able to use different credential formats and being interoperable with other protocols? Because like in Aries, for example, in Aries Present Proof, we use presentation exchange. It's used through, I guess, DIF or W3C implementations as well. Was the idea behind that just to be able to be interoperable across different presentations?
The idea is quite simple. Why should we invent our own stuff if there is already something that is used, right? And as you are correctly pointing out, it's used in Aries, it's used in WACI. And we thought, but well, we started with our own language, right? I mean, to be honest, but we quickly realized that's going to be really complicated. And we took a look onto presentation exchange, and we also have a liaison between OpenID Foundation and DIF, and we felt, well, that looks good as a starting point. And we worked very intensively with the editors and the authors. And we contributed some changes to PE2 that we felt are necessary, and then integrated presentation exchange into OpenID for verifiable presentations.
Whereas on the issuance side, because of kind of the OAuth implication, there was a need to develop your own protocol.
Well, on the issuance side, the requirements for a language for specifying stuff is not as high as on the presentation side, because you typically do not combine different credentials from different formats or something. You're just asking specifically for one credential in a certain format, And what we have is we came up with an idea how we differentiate different formats and credentials types, and just be able to have a polymorphic structure that is sent to the credential issuance endpoint. So we use standard OAuth mechanisms for that. So I mean, TE itself is presentation only. I think what we could have used is, we took a look into Credential Manifest originally, and we felt the solution to use OAuth and rich authorization request, it's more natural to OAuth, and might be simpler. And so far, that works pretty well. And we also use scopes, for example. If you just predefine a scope, it's even easier to request a credential.
So on the issuance side, I could use the issuance protocol to issue different credential formats. It's just I'm not going to start combining and doing fancy stuff with it. It's just because that typically is not something that happens on the issuance side anyways.
Exactly. So the focus on the issuance side is more, what format do I use for the issuance? What do I need to prove possession of the private key that I want to use for holder binding, all that stuff. So that's more the focus on the issuance side. And given that it is an API that I can invoke with an access token, I can also send with the same authorization multiple credential issuance requests in a row and request different credentials. So we just utilize OAuth, right? So if you want an NOCRED first, and then an MDoc, and then a JOT, you just send 3 requests, or you even use the batch request functionality that we have, and just let those 3 credentials be issued. That's pretty straightforward. Yeah.
Let me put myself in the shoes of a lead architect for, let's pick an organization, a Ministry of Transportation, and we're looking to issue digital driver's licenses to citizens. Seems like a very popular use case that's out there today. And there's a popular stack that exists today through the ISO 18013 5 and 7 coming on the MDL side of things. If I'm looking at different implementations there, maybe I like issuing a driver's license in an MDoc format. Is there a reason why I would use OIDC for verifiable credential issuance versus using the proprietary MDL issuance protocol? Is this kind of one of the biggest competitors you see now to OIDC for verifiable credentials? And are there reasons why you would suggest perhaps using OIDC for verifiable credential issuance versus something like the MDL proprietary issuance protocol?
So, I mean, ISO 18013-5 is a real milestone when it comes to, I would say, a pragmatic solution for verifiable credential, because it reaches a certain security level that you, for example, cannot reach with NOCREDs due to the highly sophisticated cryptographic algorithms that are being used. So you can, for example, anchor your cryptographic key in hardware, which is of utmost importance if you want to prevent replay of a credential, right? So I really applaud to ISO's work on that. When it comes to issuance, 18013-5 doesn't really have an issuance protocol. So, and what I have heard is that, or the perception from the market is, if issuers want to issue, they do that in a wallet specific way. So they do that for the different wallets differently, which causes cost and complexity. So the answer to your question is, I would use our OpenID for verifiable credential issuance as the interoperable way to issue such credentials. And that might be one of the reasons why ISO 23-2020-3 also incorporates OpenID for verifiable credential issuance as one of the options for an issuance protocol. There's also a ISO-specific protocol. The advantage of VCI always is it's credential format agnostic. So if you're an issuer and you want to issue MDLs in different formats, for example, in the JSON format as well, OpenID for verifiable credential issuance might be an option you might consider. And there are states in the US, for example, that plan to issue mobile driver's licenses in MDoc and other formats, and they are embracing OpenID for verifiable credential. Most notably California. The European Commission embraces OpenID and it will play a certain role in the implementation of the European Digital Identity Wallet. And if we come back to your question, interestingly, the European Commission and the member states decided to utilize ISO, because ISO is one of the top level standardization bodies. They use the protocol for proximity, so for presentation of credentials via Bluetooth, low energy, NFC, and so on, and the MDOC format. But on the other hand, they also decided to use OpenID for the online use cases, and along with SD-JOT, selective disclosure JOT. So we will see two credential formats and different protocol suites for proximity and for online. And I mean, it's not officially published yet. We expect publication of the ARF soon. That's what I have been told. So up until then, this might be still in flux. But independent of what the European Union decide, I guess that is a signal to the market, because they have spent months to really find out what they can do to really roll out decentralized identity capabilities to several 100 million citizens across the European Union. So I think that's a big milestone, and I'm really happy to contribute to that.
And I think the general sentiment too is it's still early to just say, hey, we want to go in a specific direction and pick a specific stack. I think we've clearly articulated that there are different solutions to different problems that are out there today. And by having these work alongside each other, it just creates more powerful interactions for everyone involved, really. And so it'll be very interesting to see over the next, let's call it 18 months, 2 years, the types of scenarios we're going to be able to see between OIDC for verifiable credentials, between the whole DIDCOM, between the Aries implementations for different trust tasks, between MDL. These things all playing together are going to be very powerful. And I guess my suggestion to anyone looking to invest in this is just to try these different approaches out together, because I think you're going to find that they solve different problems. And by working together, they create more powerful solutions overall.
Yeah, I mean, your podcast contributes to that as well. I mean, people get the information to make their own decisions. I can also say we have been working on credential format comparisons, so there is a lot of material available for that. I might share a link so you can put that in the description. And we're also going to do a protocol comparison and all that stuff. So I guess attending conferences where people speak about their experience, real world experience with different protocols, will help people to really build their own mind and decide. I mean, it's difficult right now, but on the other hand, we will see, based on really practical experience, in the end, what the direction is we need to take, right? And what protocols can be used for what, and so on.
Although just from my perspective, it seems less difficult than it was a year ago. Like, we're going in a direction where and like you said earlier, it's nice to hear people that represent different stacks just honestly talking together about kind of the pros, the cons. And so I think that's a positive sign, and having conversations about trust frameworks and how much restrictions should be put and stuff like that. These are kind of almost the more important conversations now that need to happen.
And it's important that those people talk with each other, because there are just a few of us, because what we do is really a niche, right? We always need to keep that in mind, right? It's just a couple of 100, 200 people that in the end should work together and learn from each other.
Thanks for tuning in today. Hope you enjoyed the conversation as much as I did. To stay up to speed with future episodes, or to catch up on ones you may have missed, make sure to check out the SSI Orbit podcast on your favorite podcast platform, and make sure you subscribe. If you have any questions, comments, or wish to see someone in particular on a future episode, you can find me by searching Mathieu Glode on LinkedIn or Twitter. Feel free to reach out to me directly and I'll get back to you. See you all next time.